Good evening, guys. Are you able to hear me?
Yes, sir.
Yeah. Okay. So we'll get started. All right. So you're able to see my screen, right?
Yes, sir.
Okay. So we'll start with the first question for the part test one. The first question asks, write the necessary condition we need to write the necessary conditions for the phenomenon of total internal reflection to occur. That is the first part of the question. And write the relation between the refractive index and the critical angle for a given pair of optical media. So what is the answer for the first one, guys? So what is the answer for the first one? What is a necessary condition for you to observe the total internal reflection? Answer is, you need the ray to travel from denser to rarer medium. And secondly, you need the angle of incidence to be greater than the critical angle. So if these two are happening, then we can say the total internal reflection is going to occur. Now, with respect to the second part of the question, let's say there is an incident ray with the angle of incidence as I, or I call it as C. Okay, which we call it as a critical angle. So when the angle of incidence is critical angle in the denser medium and the ray is traveling to the rarer medium, then what will happen is the angle of refraction will be 90 degrees. Then if I take the refractive index of the denser medium as mu1 and the refractive index of the rarer medium as mu2, then mu1 into sine C will be equal to mu2 into sine of 90 degrees by applying Snell's law, right? And sine C will be equal to mu2 divided by mu1 into sine 90. We know that sine 90 is 1. So C will be equal to how much? Sine inverse of mu2 divided by mu1. This is what they asked us. That is, you need to write the critical angle in terms of the refractive index of the given pair of optical media. I hope it is clear, right?
Yes, sir.
Perfect. So I have attached the solution also here. Once the discussion is over, I'll be sharing the sheet. You can go through the solutions also. Second, so there is a prism of refractive index √2 that has a refracting angle of 60 degrees. At what angle must the ray be incident on it so that it suffers a minimum deviation? Okay. So how to solve this? So what are all the given data? Mu is equal to √2. refracting angle is the angle of the prism, that is 60 degrees. At what angle must it be incident so that it suffers total internal reflection? So we know this mu is equal to, at what angle must a ray be incident so that it suffers a minimum deviation. So during minimum deviation, what is the condition? A is equal to R1 plus R2. Right? Similarly, delta M is equal to I plus E minus A. Actually, delta is I plus E minus A. But during the minimum deviation condition, I will be equal to E, which implies delta M is equal to 2I minus A, which implies A plus delta M by 2 is equal to 2I. So our job is to find the angle of minimum deviation. Once you get it, then you can substitute it here so that you will get the angle of incidence. For that, what I'm going to do is, I'll apply Snell's law at the boundary. So if I take the angle of incidence as I, then the angle of refraction, I will call it as R1. Okay. We know that during minimum deviation condition, R1 is equal to R2 is equal to R. So A will be equal to 2R, which implies R is equal to 30 degrees. So I can write 1 times sine I is equal to mu times sine R, which implies sine I is equal to mu into, what is the value of sine R? It is sine 30 degrees and mu is root 2 and 30 is, sine 30 is half. So you will get 1 by root 2. So sine I is equal to 1 by root 2. I will be equal to 45 degrees. So this is going to be the angle of incidence at which minimum deviation condition occurs. Clear?
Yes, sir.
Right. So the next one is, you have X-rays of wavelength lambda 1 fall on a photosensitive surface. You have a photosensitive surface on which rays of wavelength lambda 1 are incident. Okay. They are emitting electrons, assuming that the work function of the surface is neglected. So W naught, if I take it as 0, prove that the de Broglie wavelength of the electrons emitted is this much value. Okay. Now let us think of how to solve it. So here, if you observe, this question is very tricky one. So why it is tricky is because you have two wavelengths. One wavelength is lambda 1 and the other wavelength they are trying to talk about is de Broglie wavelength. Okay. So can you tell me what does de Broglie wavelength represent? Lambda is equal to, so if I say lambda is the de Broglie wavelength, it is equal to h divided by m into v, or I can call it as h divided by p, where this p represents the momentum of electrons. Right? When this is going to be the case, what is Einstein's photoelectric equation?
H nu is H nu minus work.
Okay. So h nu, the amount of energy that you supply, is utilized for overcoming the work function plus half m v max square. Right? This is nothing but kinetic energy. So can I write kinetic energy is equal to h nu in this case, because what is W naught? They told W naught is 0 because they told work function of the surface can be neglected. When Ke is equal to h nu, but how do you write Ke in terms of momentum? I can write it as p square divided by 2m is equal to h into, in the place of nu, I can write it as c divided by lambda 1. So p square will be equal to 2m into hc divided by lambda 1. Right? Then what is the value of p? P will be equal to square root of 2m hc divided by lambda 1. So let me call this as equation number 2 and let me call this as equation number 1. Then the de Broglie wavelength will be equal to h divided by p, p is nothing but root 2 mhc divided by lambda 1. This h in the numerator gets cancelled root h times. So you'll be left out with root of lambda 1 into h divided by 2m into c. So this is the required answer. Are you guys able to understand? So this is a very, very important question. Mark it as important and try it again. So lambda 1 into h divided by 2m into c. Okay. So moving on to the next one. Define the power of length. So power of length is defined as the reciprocal of focal length. You can write this. Okay, the reciprocal of focal length of the given length is what we call it as power of. Yeah, please tell me.
Can you show the third question answer one more time, sir? I'm actually copying it because I didn't write properly. So, one second.
Yeah.
Thank you, sir.
Yeah.
Yes, sir. I copied, sir. Thank you, sir.
Okay. So don't worry, I'll be sharing the sheet after the class. So concentrate. Okay. So power of length is defined as the reciprocal of focal length. So if you measure the focal length in terms of meter, then unit of power is diopter, which is written in capital D. Now, you need to deduce the expression 1 by f is equal to 1 by f1 plus 1 by f2 for two thin lenses kept in contact coaxially. Okay, so let me take this as first lens, second lens. First lens focal length is f1, second lens focal length is f2. So v1 is where the image due to the first refraction is taking place. This image starts to behave like the object for the second refracting surface, and the final image is formed here at a distance v. So if you apply lens formula for first lens, then you get 1 by v1 minus 1 by u1 is equal to 1 by f1, which implies 1 by v1 is v1 only, minus 1 by u1 is u is equal to 1 by f1. Let me call this as equation number 1. Similarly, when you apply the lens formula for second lens, then you will get 1 by v2 minus 1 by u2 is equal to 1 by f2, which implies 1 divided by v2 is v minus 1 by u2 is v1 is equal to 1 divided by f2. Let me call this as equation number 2. So if I add first and second, then I'll get 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f2. So this 1 by v minus 1 by u, I can call it as 1 by f effective or equivalent focal length, which is equal to 1 by f1 plus 1 by f2. So I hope everybody understood what the meaning of f effective is. So when two lenses are in contact, what you can do is you can replace it with one of the lenses where its focal length is f effective and the focal length of the individual lens is f1 and f2. Means you're replacing these two devices with one particular device, which will do the exact work that is done by these two lenses put together. Okay. So concentrate on the content. If there is any doubt, get it clarified. Okay. Is it clear? Shall I move on to the next one?
Yes, sir. Yes, sir.
Okay. So find the position of the image formed by the object O by the lens combination given in the figure having focal length plus 10 centimeter, minus 10 centimeter, and plus 30 centimeter respectively. Okay, so focal length of the first lens is plus 10. So wherever you see plus 10, what kind of lens will come to your mind? So focal length is positive for what kind of lens? It is convex, and this is concave. Okay. Now listen, the job is very simple. Due to the first lens, find out where the image is formed. So applying lens formula for first lens. So what will you get? 1 by V1 minus 1 by U1 is equal to 1 by F1, which implies 1 by V1, we have to find it, minus 1 divided by, tell me what is U1? What is U1, guys? It is minus 30 is equal to 1 divided by F1 is plus 10, which implies 1 by V1 plus 1 by 30 is equal to 1 by 10. So 1 by V1 is equal to 1 by 10 minus 1 by 30. So 1 by V1 is equal to 30 minus 10 divided by 300, that is 20 divided by 300, and V1 will be equal to 15 centimeter. So 15 centimeter from the first lens optical center means it is formed at this point. Right? If it is 15 centimeter, then with respect to the second lens, what is the object distance? This is U2. U2 is how much? You're able to see it in the diagram itself. So U2 is 10 centimeter. So applying lens formula for second lens, I'll get 1 by V2 minus 1 by U2 is equal to 1 by F2, which implies 1 by V2 is what you need to find, minus 1 by U2 is how much? U2, since with respect to the optical center of second lens, U2 is on the right hand side, so U2 will be equal to plus 10 centimeter is equal to 1 divided by F2 is how much? F2 is going to be minus 10. So this and this will get cancelled, which implies 1 by V2 is 0 and V2 will be infinity. So the final image due to the second lens is formed at infinity. Now this object at the image formed at infinity is going to act as an object for the third lens. So we know the fact, we need not apply lens formula. When object is at infinity, where is the image formed? Image is formed at the focus. So when it is going to be at the focus of the third lens, you already know the focal length. So what is going to be the image distance? Focus of third lens. So answer will be V3 is equal to 30 centimeters. So you should not write the answer in as 30 centimeter in V. You need to write 30 centimeters from the optical center of the third lens. 30 centimeter from where? From optical center of third lens. So suppose if they want to twist the question, right, they can ask you, what is the image distance with respect to the initial object distance? Then what you need to do? It is 30 plus 5 plus 10 plus 30. That is how you need to write. Okay. So answer is going to be something like this. Okay. I hope it is clear. The problem is very simple. You need to apply the lens formula thrice. Okay. So with the hope that it is clear, I'm moving on to the next question. So there is a monochromatic light of wavelength 589 nanometer is incident from air on a water surface. If the refractive index of water surface is 1.33 or 4 by 3, find the wavelength, frequency, and the refractive index. One minute. Okay. Solution. Lambda is equal to 589 nanometer. Light is incident from air onto water surface. If mu is the refractive index of water is 4/3. Find the wavelength, frequency, and speed of the reflected light. So how to solve this, guys? So refractive index of water is equal to 4/3. So how do you define refractive index as? It is defined as the speed of light in air divided by the speed of light in the given medium, which implies VW is equal to 3/4 times C. So 3/4 into 3 into 10 power 8, or this is going to be 0.75. So 2.25 into 10 power 8 meters per second is the speed of the light in this medium, in water medium. Okay. Secondly, they asked about frequency. So when you know wavelength, how will you calculate frequency? Frequency is equal to C divided by lambda, which implies nu is equal to C is 3 into 10 power 8 divided by 589 nanometer. Right. So 589 nanometer means 3 into 10 power 8 divided by 589 into 10 power minus 9. So how much is the value going to be? So find the wavelength. Yeah. So how much ever is this is going to be, calculate that value and try to understand that when light travels from one medium to another, what parameter does not change? What are the parameters that will not change out of the wavelength, frequency, and speed? So frequency remains constant. So we calculated it with respect to air medium. So it is going to be a constant value. Okay. That is one thing. And lastly, 1 minute. Yeah. So they asked about the wavelength of the light in this second medium. So how do you calculate the wavelength of light in second medium? We know that refractive index of water divided by refractive index of air is equal to speed of light in air divided by the speed of the light in water medium. Right. Right. But speed of light in air is how much? How do you write it in terms of wavelength? Can I write it as F into lambda of air divided by F into lambda of water? Right. F and F will get cancelled because F stands for the frequency. Here I wrote it as mu. So I can write it like this. So refractive index of water is 4/3, air is 1. So refractive index in air medium is 589 nanometer divided by the refractive index in water is this thing. So lambda W is equal to 3/4 into 589 nanometer, which comes out to be somewhere around 443 nanometer. Okay. So it is 443 nanometer. Secondly, you have a double convex lens which is made of glass of refractive index 1.55 with both the faces of same radius of curvature. Find the radius of curvature required if the focal length is 20 centimeter. So second problem is R1 is R, R2 is minus R. So this is how a convex lens is R1, R2. So we are going to use lens maker's formula. 1/f is equal to mu minus 1 into 1/r1 minus 1/r2. If you substitute r1 as r and r2 as minus r, you will get mu minus 1 into 2 divided by r. Okay. So 1 by focal length. So focal length of convex lens is positive. So 1 divided by 20 is equal to mu minus 1 into 2 divided by R is how much? That is what we need to find. Yeah, R is what you need to find. And the refractive index is given as 1.55. So 1.55 minus 1 is going to be 0.55, which implies R is equal to 0.55 into 2 into 20. That's it. So that is going to be 5.5 into 2, 11. 11 into 20 is 220 centimeter. Am I right? So it is 1.1. 1.1 is 2.2. Sorry. It is going to be 22 centimeter. 220 centimeter is very big. So it is 22 centimeter. Am I clear, guys? Yes or no? Okay. So there are two concave glass refracting surfaces, each with radius r is equal to 35 centimeter and refractive index is equal to 1.5. Are placed facing each other as shown in the figure. A point object O is placed at a distance r by 2 from one of the surfaces as shown. So r by 2 as on. Okay. Find the separation between the images formed by the refracting surface. So how to solve this, guys? Can someone tell me the idea? What are we supposed to use? See, if you guys are not going to speak, I can record and give you the session. No? What is the purpose of live class?
Spherical surfaces.
Your voice is breaking. So you need to apply. I could hear some spherical. You can apply.
Reflection on physical surfaces.
Correct. So what is going to be the value? What is the formula? Mu2. There is a big
N2
formula.
by
Right?
V minus N1 by U equals N2 minus N1 by V.
Very good. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Right. Where mu2 is what? Mu2 is the refractive index of the medium where the image is expected to form. And mu1 is the refractive index of the place where the object is kept. Right. Now tell me how to apply the formula in this problem. So this point is A, right? So they have given this as the first surface. Applying this formula at first refracting surface, what do we get? Mu2 is the refractive index of glass. So mu2 is how much? Find the separation. So mu2 is given as 1.5. Both are glass medium. So 1.5 divided by V, that is V1. This distance, I call it as V1 because they have given this as I1 minus mu1 by U. So mu1 is 1, that is the air medium, divided by, can you tell me what is the value of U? Can someone tell me what is the value of U? It is R plus
R by 2.
Very good. R plus R by 2. It is 3R by 2. But since it is on the left-hand side of it, we are going to apply the sign convention. So, minus 3 into R is 35 divided by 2 is equal to mu2 minus mu1. 1.5 minus 1 divided by R. So, what is the value of R? It is 35. So, 35 again with respect to the object. Since it is on left hand side, I will take it as minus R. Okay. So taking all these points, tell me what is going to be the value of V1?
Sir, for first surface, object is on right only.
So you're taking this as the origin.
Yes, sir.
1 minute, ma. Yeah. So 1 minute. Yeah. So I've taken this as the origin, right?
Yes, sir.
Now, if you take this as origin, then we'll try to find out the value. This will be minus. Okay. According to your logic, both will be plus only. Now tell me what will be the value. So 3 by 2 times V1 minus 2 divided by 105. 1 divided by 70, which implies 3 by 2 V1 is equal to 1 by 70 plus 2 by 105. So how much is answer goes? Uh, 105 plus 140 divided by 70 into 105. So 245 divided by 70.05. Correct? So 2 will cancel this 35 times. 3 will cancel 81 times. So V1 will be equal to 35 into 105 divided by 81. Okay. So calculate that value, and that value should come out as, let me check it. That value should come out as 45 centimeter. So that value is 45 centimeter. Now, if this is 45, okay. If this is 45, then how much will this distance be? Okay, actually, 1 minute. I was thinking that image formed I1 is going to act as the object. No, that's what a point object was placed at distance. Find the separation between the so this refracting surface will form an image at I2, the second one, and the first one will form an image at I1. You need to find this distance of separation. So at second refracting surface, if you apply the same logic, then 1.5 divided by V2 minus 1 divided by V1 is how much, guys? Sorry, U1. R by 2. Now, can I take it as 0? Sorry, negative.
Yes.
That is minus 35 by 2 accepted. So that is equal to 1.5 minus 1 divided by, what is going to be the value of R2 now? That will be minus 35 divided by 2. So which implies 3 by 2 times V2 is equal to minus 2 by 35 minus 2 divided by 1.5 by 2. So 2 and 2 will get cancelled. You will have minus 35. Right? So 1.5 minus 1 divided by R. Sorry, I made a mistake. R is minus 35 now. So this will be 3 divided by 2V2 minus, plus 2 divided is equal to 1.5. So it is minus 1 divided by 70. So 3 divided by 2V2 will be equal to minus 1 by 70 minus 4 by 70. That is minus 5 divided by 70. Correct? Did I do any mistake? So 3 by 2 times V2 minus. So this is equal to minus 1 divided by 4. So V2 minus 21 centimeter. Is everyone clear what I did? So V2 is minus 21 centimeter from where? From the second refracting surface. This is minus 21 centimeter. And this distance is how much? It is plus 45 centimeter. So out of 70, 45 is gone and 21 is gone. Then how much will be the distance of separation between both? So why did I take 70? Because R plus R is going to give you 70. From 70, you remove 45 and you remove 21 also. Ignore the minus sign. Minus sign indicates that it is on the left-hand side. So 70 minus, how much will we get? 56. So 70 minus 56 is 14 centimeters. That is the distance of separation between these two. Clear, guys? So if I have to give you a conclusion to this problem, the object is placed here. Find the image formed due to the first surface. Find the position of the image formed due to the second surface. And 70 subtract the sum of the distances from each refracting surface. That will give you the answer. Here. So there is a slightly tricky problem. Only is you need to know this, and you need to know the fact that you need to apply sign convention. Okay.
Yes, sir.
So next one is easy. So in the study of photoelectric effect, the graph between the stopping potential V and the frequency of the incident radiation of two metal rods PQ are as shown. Has higher threshold frequency. So the frequency is a multiple of 10 power 14 hertz. Okay, 10 power 14 hertz. So which of the two metals has highest threshold frequency? So what is the answer? So what is the relation between stopping potential and frequency? So we know that h nu is equal to W naught plus K max. But K max is written as minus E times V naught. So h nu naught is equal to W naught minus EV naught. So EV naught is equal to minus h nu plus W naught. Okay. So when nu is 0, okay, when nu is 0, what is about EV naught? So EV naught will be equal to W naught. Means this will be the point where it will be W naught divided by E. So observe, V naught will be equal to W naught divided by E. So this point will decide which one has greater threshold function. So as you see, frequency, as you keep moving away, the frequency value is going to be increased. So Q is going to be the one which has greater threshold frequency. So Q is the answer. Similarly, you need to find the work function of the metal which has greater value. So W naught is equal to H into nu naught. Right. So H into nu naught means it will be W naught is equal to H is 6.626 into 10 power minus 34 joule second. Okay. Into V naught is how much? V naught is 6 into 10 power 14. Okay. So when you multiply these two, you will get an answer in terms of joule. So generally what happens is work function, we don't report it in terms of joule. We always convert it in terms of electron volt. So whatever answer you got in the numerator, divide it with 1.6 into 10 power minus 19. And that will be written as electron volt. Okay. Next is find the maximum kinetic energy of electron emitted by a photo by light of frequency 8 into 10 power 14 hertz for this metal. So you know the formula that Ke max is equal to h nu minus h nu naught from Einstein's photoelectric equation. So if I take out h, I'll get 6.626 into 10 power minus 34 into what is the frequency of the light that is incident? It is 8 into 10 power 14 minus the threshold frequency is 6 into 10 power 14. So 6.626 into 10 power minus 34 into 2 into 10 power 14. That will give you the answer. In terms of joule, again, to convert that from joule to electron volt, you need to divide it with 1.6 into 10 power minus 19. That will give you the value of kinetic energy in electron volt. Okay. So the maximum kinetic energy of photoelectrons emitted is doubled when the wavelength of light incident on the photosensitive material changes from lambda1 to lambda2. So we need to derive the expressions for the threshold wavelength and work function for the metal surface in terms of lambda1 and lambda2. So how to solve this problem, guys? So the only equation that we have in our hand is what? Einstein's photoelectric equation. Right. So I can write h nu is equal to h nu naught plus Ke max. So what is happening? The maximum kinetic energy of the photoelectron emitted is doubled when the wavelength is changed from lambda1 to lambda2. So hc by lambda1 is equal to h nu naught plus K. hc by lambda2 is equal to h nu naught plus 2K. So did you understand what I did? Why did I change h nu naught? So why didn't I change h? You guys there?
Sir, could you repeat your question?
What is h nu naught in both the cases?
It's the same
Because
metal, right,
if you
sir?
take about, yes, you talk about the same metal, the work function is going to be the same. So if I subtract these two, what I will get is hc divided by lambda2 minus hc divided by lambda1 is equal to K. Okay. Now what you can do is take this and substitute it in the first equation. Then hc divided by lambda1 is equal to h nu naught plus, in the place of K I can write as hc by lambda2 minus hc divided by lambda1. So take these two to the left hand side. So hc divided by lambda1 plus hc divided by lambda1 minus hc divided by lambda2 is equal to h into nu naught. So h will get cancelled. Take out that c. 2 divided by lambda1 minus 1 divided by lambda2 is equal to mu naught. So what you will get here is 2 lambda2 minus lambda1 into c divided by lambda1 lambda2 is equal to mu naught. Are they asking threshold frequency or threshold wavelength? So they ask the threshold wavelength. So mu naught is equal to c divided by lambda naught. So c and c will get cancelled. Lambda naught will be equal to lambda1 lambda2 divided by 2 times lambda2 minus lambda1. Okay, this is what is the threshold wavelength in this scenario. Okay, and you need to find the work function of the metal as well. So work function is this thing only, without cancelling h. So work function is h naught is equal to 2hc by lambda1 minus hc by lambda2. So this is the work function. You need not memorize these formulae. It is all about how you bring in the relation. Okay. These are all little standard problems. Unless you know the basic, you'll not be able to test them. Okay. Is it clear, guys?
Yes, sir.
The last two problems. So using Rydberg's formula, calculate the wavelength of the first 4 spectral lines in the number series of hydrogen atom spectrum. One
Sir,
by
I have
lambda
a
is equal
doubt
to
here, sir.
N by
Can
R.
we leave the answer with R, sir, or should we substitute the value of R?
It's better you remove it. You need to remove it. Okay. So R value, I hope you guys know it, 1.097 into 10 power 7 meter inverse. So this value is expected for you to remember. Okay. So 1 by lambda 1, if I take R into 1 by, so for the first spectral line, where should the electron jump from? It should jump from 2 to, sorry, it should jump from 3 to 2. So 1 by n1 square is 4 minus 1 by n2 square is 9. So what you can do is 5r divided by 36. Right. So lambda 1, is this what you're asking? 36 divided by 5r?
Yes, sir, we can leave it like that, sir.
You can actually leave it, but it again depends on who's correcting your paper. Okay. So I suggest you convert it. Okay. Similarly, lambda 2, what will you get? Here, what will get replaced? For the second line, you will get 1 by 4 minus 1 by 16. Am I right?
Yes, sir.
So, then 1 by lambda 2 will be r into 1 by 4 minus 1 by 16. So 16 minus 4, 12 divided by 64 is what you're going to get. Or I'll get 3 divided by 16. So 1 by lambda 2, which implies lambda 2 is equal to 60 by 3r. So it keeps going like this. If you check the solution, right, they would have found the values. By the way, you know the name of the line, right? In Balmer series, when an electron jumps from third orbit to second orbit, you call it as H alpha line. Similarly, fourth to second, you call it as H beta line. So this is applicable only for Balmer series because it is visible. Okay. So sometimes they can ask you find the wavelength of the H alpha line in Balmer series. You should not get confused. H alpha line means when the electron jumps from third orbit to the second orbit. Okay. Next is using the Bohr's model, calculate the speed of electron and hydrogen atom in the n is equal to 1, 2, and 3 levels. Okay. So how to calculate this? mv square divided by r is equal to mv square divided by r is equal to kz e square divided by r square. So r and r will get cancelled. Right? So which implies v is equal to, or v square is equal to kz e square divided by mr. Right? Are you guys able to understand what I did?
Yes, sir.
Right. So what is the formula for r, guys? It is kz e square divided by m into r is 0.53 into n square divided by z. N square divided by z. But here, n is you need to put 1, 2, and 3, and they told about hydrogen atom. So hydrogen atom z is equal to 1. Okay, here also z equal to 1. So v square will be equal to k is 9 into 10 power 9 into the charge of the electron is 1.6 into 10 power minus 19, the whole square, divided by mass of the electron is 9.1 into 10 power minus 31 into 0.53 into n square is 1, and this is in terms of angstrom. So 0.53 you can write it as 0.53 into 10 power minus 10 into you have this n square. No, in this n square put 1.3, you will get 3 different answers, and those are the velocities they are expecting. Okay. Don't worry, the problem will not be this complicated of you calculating the values. If you know how to derive it, that's enough. Okay. Second is you need to calculate the orbital period in each of these cases. So T will be equal to, what is the time period? time period is equal to distance divided by speed. So 2 pi r1. So T1 will be equal to 2 pi R1 divided by V1. T2 will be 2 pi R2 divided by V2. And T3 will be 2 pi R3 divided by V3. So in the place of R1, you'll write it as 0.53 into N1 square. In the place of V1, whatever is the value you have derived, you'll put it there. Okay, you understood the problem?
Yes, sir.
Okay, so with respect to this problem, even if your final answer is wrong, right? If your approach is correct, you will get marks. So I'm just doing it for this time because the calculation is little tedious. Okay. Lastly, so the refraction of light is a change in the path of light as it passes obliquely from one transparent medium to another according to the law of refraction. Sin I by sin R is equal to mu2 by mu1 is called refractive index of the second medium with respect to the first medium. From the refraction at convex refracting surface, spherical surface, we have mu2 by v minus mu1 by u is mu2 minus mu1 by r. Similarly, at concave spherical surface, an object lies in the error medium, we have mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. And the object lies in denser medium, we have this thing. So everything is almost the same, except the fact that mu2 and mu1 are interchanged. Okay. So the question is, the refractive index of a medium, if you take it, what are all the parameters on which it depends on? It depends on the nature of the medium. So which one is more important? It depends on the nature of the medium. It depends on the wavelength of the light used. It depends on the temperature. Which one is right?
Nature.
Which one is right? So it not only depends on the nature, it depends on the wavelength of the light used also. Because in prism, right, depending on what wavelength you are using only, you are getting the spectrum. Okay. Similarly, it depends on the temperature as well, because optical density can be changed with the help of temperature. So refractive index depends on all these parameters. Okay. So remember this. It depends on all the three parameters. Secondly, a ray of frequency 5 into 10 power 14 hertz is passed through a liquid. The wavelength of the light measured inside the liquid is found to be 450 into 10 power minus 9. The refractive index of the liquid is. So refractive index is equal to C divided by V. So C is 3 into 10 power 8 divided by, they have given frequency and wavelength. So frequency and wavelength means you multiply them 5 into 10 power 14 into 450 into 10 power minus 9. You solve this, you will get the answer, and the answer comes out to be 1.33. See, 0.75 is eliminated because refractive index can't be less than 1. Okay. Similarly, if the other options are also less than 1, then you can eliminate them and you can go with the answer which is greater than 1. But in this problem, you need to solve it. So it comes out to be 1.33, which is for water medium.
Sir.
Tell me.
Sir, due to the refractive index of a particular medium, the wavelength of the light will change. But then because of the wavelength of light...
Depending on what wavelength you are using, because there is something called as Cauchy's equation. Okay. Where you will have an equation like this equal to A plus B by lambda plus C by lambda square is actually not a part of your syllabus. Have you heard of Rayleigh's scattering?
No, sir.
No, right? No problem. So you know the scattering of light, right? When light hits these particles in the atmosphere, it starts scattering. So it is wavelength. So this is called as Cauchy's equation. Remember it next time. If somebody asked you, we would have learned something like this. Dispersion concept is, white light is passed through the prism. It splits into 7 different colors. That is basically the concept of colors. Why is it happening? Because each wavelength will change the refractive index of that medium. So depending on what color light is passed, the refractive index changes, and that is the reason why you are able to see the different colors once the second refraction is undergone by the medium. Okay, and generally, if you go for higher studies, they give you the explanation according to Cauchy's equation. So since you asked me this question, wavelength of light, how is it dependent? It is inversely proportional according to this equation.
Okay, sir.
So third, there is a ray of light which is incident at an angle of 60 degrees on one of the faces of rectangular glass slab of refractive index 1 point. Refraction, the angle of refraction is. It's very simple. So outside medium is air. 1 into sine 60 degrees is equal to refractive index of glass slab is 1.5 into sine r. So sine r will be equal to root 3 by 2 into 2 divided by 3. Cancel them. It will be 1 divided by root 3. So 1 divided by root 3, or I can write it as root 3 divided by 3 itself. Did I make any mistake? So it is going to be 3 by 2. So left hand side is root 3 by 2 into 1.5 is 3 by 2. This goes to the other side as 2 by 3. This and this will get cancelled. Root 3 is 1.732 divided by 3. How much is it? 0.58 something. This will be the answer. Okay. So it is sine inverse of 0.58. Okay. Fourth. So a point object is placed at the center of a glass sphere of radius 6 cm and refractive index 1.5. The distance of the virtual image from the surface of the sphere is. So there is a glass sphere of radius 6 cm and refractive index 1.5 cm. There is an object which is placed at the center. Okay. So this is 1.5. Outside medium is air. Now tell me the formula mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. So mu2 is 1 divided by v minus 1.5 divided by minus 6 is equal to mu2 minus mu1. So the minus 0.5 divided by r is again minus 6. So it implies 1 by v is equal to minus 1.5 by 6 plus 0.5 by 6. That is minus 1 divided by 6. So v will be equal to minus 6 centimeters. So minus here indicates that it is a virtual image. Okay. Last problem is in refraction, light waves are bent on passing from one medium to the second medium because in the second medium, what is different? Frequency is different? No. Why? Because it is the characteristic of the source. Okay. The coefficient of elasticity is different. Okay. The speed is different. The amplitude is smaller. So what actually happens? Generally, when somebody asks you about refraction, right? The main reason why the refraction is taking place, we know this from the Huygens principle also. It is mainly taking place only because the speed of the light about the media will change. Okay, so that is the reason. Right, I hope it is clear, no? So having all these points in mind, prepare accordingly. So if you have any doubts, right, any conceptual doubts or anything, you can reach out to me on the student support number 6369 210 899. So there is the number on which you can reach out to me personally for doubts. So that's it from my side, guys. If you're clear, we can wind up.
Thank you, sir.
Yeah.
Thank you.
Thank you, sir.
Yes. See you.